All right, here's a Khan Academy problem where the scale factor is 1/2. So let's remember, if the scale factor is 1/2, then the shape is going to get smaller. Really what's happening is every point will be half as far away from the origin as it used to be. And so the way I like to do these problems is I like to count from the origin to the point and then cut that in half. So here's what I would do. From the center of the, I'm sorry, I said the origin, but the center of dilation is what I meant. P is the center of dilation. So every point will get half as close to P as it used to be. So from P to B, I used to count up 2, left 2. Well, if I divide that by 2, which is the same thing as multiplying by 1/2, then I would only go up 1, left 1. So that's where my new B will go. Do you see how it used to be this long and now it's just this long? It's half as far away as it used to be. Okay, so P to A, from P we go up 1, 2, 3, up 4, right 1, 2, 3, 4, 5, 6, 7, 8. Up 4, right 8. If I cut that in half, it's up 2, right 4. Oops. Okay. Now, one way we can tell that I did that correct was, do you see how this line used to be 10.2 long and now this one is 5.1? So it cut it in half perfectly. And then C, from P to C, let's see, I used to go down 1, 2, 3, 4 over 1, 2, 3, 4. If I cut that in half, it would be down 2 over 2. Down 2 over 2. Okay, so did every point get half as close from the origin as it used to be? Yes, it did. And we should be able to check our answer. I love that sound. All right, let's do another one. Okay, so this one, the scale factor is 3/4. So the center is A. Now, first, let's forget the scale factor for now. Let's just talk about what's going to happen to A if A is the center of dilation. Nothing will happen to A. All the points will get 3/4 as close as they used to be, but A, since it's the center, will stay exactly where it is. So let's just look if we can rule out any of them that move A. See how A here moved? A should not move. A and A prime are in the same spot. That's perfect. Here the A moved, so it's not C. And here the A did not move either. So we can either say it's D or B. Okay, so let's think of what do we do with the scale factor. So if we multiply by the scale factor of 3/4, let's look at one of our possible ones. Okay, so let's say this line, this A to B, used to be 1 unit long. If I multiply by 3/4, then I'll get 3/4. Doesn't this line look like it's 3/4 of 1, right? Let's go over here. So this one, if A to B was originally 1 and you multiplied by 3/4, you should get 3/4, right? It looks like this one is 1/4 of it. So remember, we want the scale factor to match how close each point got to the center of dilation. So if C used to be this far away, I would say that C prime is 3/4 of that. And the same with B. Okay, so this answer would be B. Let's do one more. For these ones, I like to actually drag the dots, the vertices, right on top of these vertices. And what I do want to say is the angles will not change. So see this right angle? When I dilate this, I'm still going to have a right angle in my triangle. The angle sizes do not change, only the side lengths of the triangle. So this scale factor is 3. So we can expect this triangle to get 3 times. It's not necessarily 3 times bigger. It's every point will be 3 times as far away from P as it used to be. Okay, so let's do A. That's kind of an easier one. A is 1, 2, 3, 4 units away from P right now. See where I'm getting that number? 4 units. Well, 4 times 3 is 12. So A now needs to be 12 units away. Okay, B right now from P to B is just 3 units. Well, 3 times 3 is 9. B prime needs to be 9 units away. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. And now C, you could kind of cheat a little bit because you know that we need a right angle. So C should end up right here, but let's double check. Let's use the method that I used in the beginning of this video. From P to C, I go down 1, 2, 3 and over 4. So if I multiply that by 3, I'll go down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over 4 times 3 is 12. So I'll go over 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can already tell they give it to us right here. So see how from A to B used to be 5, and now it's 15. From A to C used to be 3. 3 times 3 is 9. C to B used to be 4. 4 times 3 is 12. So everything got 3 times as far away from the center of dilation.